Let's start. Remember, step number 1 is S, single rational inequality. If we evaluate our given, on the left side is a single rational expression, on the right side is 0. Therefore, this is a goal. This will be our starting inequality. Let's go to step number 2. Step number 2 is M. We need to solve for the meaningful numbers. Let's start with the numerator. For the numerator, that's 3x equals 0. Divide all by 3, so x is equal to 0. After solving for the meaningful number, we need to substitute it to our original inequality. So we have 3 times 0 over 5 times 0 minus 2. That's 0 less than or equal to 0. Let me give you a technique. Another technique number 2. Technique number 2 is if the inequality sign is greater than or less than, then the numerator is a false. But if there is an equal to, then the numerator is a true or a part of a solution. If you check here, 0 is less than or equal to 0. That means that the numerator is a true or a part of the solution. For the denominator, we have 5x minus 2 is equal to 0. 5x is equal to transposition 2 divided by 5, so x is equal to 2 over 5. Remember, I gave you a hint a while ago. I told you that for the denominator, it's always false because the meaningful number for the denominator will always make the function or the inequality undefined. Next, let's go to step number 3. In step number 3, we use the meaningful numbers to plot our number line. I'm sorry for my number line. That's negative infinity and positive infinity. We have 0 and we have 2/5. Now, we draw 2 circles. And since the numerator is a true, then we need to shade 0, the circle for 0. We call it close or shaded. Since the denominator is false, then it remains open. Let's go to step number 4, test values. For test values, we have 3 intervals, right? If you'll check, this is interval 1, this is interval 2, and the last is interval 3 in the number line. So let's now have our table for the test values. Let me make it longer this time. Substitution, then remarks. We have 3. So for the first test value, less than 0, we could apply -1. For the second one, hope this will fit. For the second one, we have between 0 and 2/5, you could have 1/5. Then for the last one, greater than 2/5, we could have 1. Let's do the substitution. Let's go back to the original inequality. That's 3x over 5x minus 2 less than or equal to 0. Let's start. That will be 3 times -1 over 5 times -1 minus 2. I'll just make an arrow like this. -3, I'm solving on the left-hand side only. -5 minus 2. That will be -3 over -7. So our final answer is 3/7 less than or equal to 0. Then evaluate. Is this true or false? That is a false. Let's go to the second one. Let me change the color so that it won't confuse everybody. That's 3 1/5 over 5 1/5 minus 2. Then I'll work on the left-hand side again. That's 3/5 over 1 minus 2. That becomes 3/5, 3/5 divided by -1. That will be -3/5 less than or equal to 0. And upon evaluating this one, you see it is true. Next, let's go to our third test value. We have 3 times 1 over 5 times 1 minus 2. Working on the left-hand side, 3 over 5 minus 2. That means 3/3 is 1, less than or equal to 0. And this statement is false. So we just deal with the true. Where's the true? 1/5. In what interval? The middle interval. This is the only true interval. So now, let's now write our final answer. Step number 5. The interval expressed in interval notation. You see, this is the only true, right? So it says from 0 to 2/5. 0 is shaded, so we use a bracket. 0, comma, up to what number? 2/5. And since 2/5 is unshaded, then we just write a parenthesis. Any questions? You take a photo of that again. And send via Telegram. Okay, do you have questions?